Example 5.2, calculate vout and the current iout using node and simple circuits. My preferred way is definitely using simple circuits for the vast majority of the op-amp circuits. So instead of starting out with node, I'm going to start out with mesh. So here we go. We're going to do the simple circuits method. The reason why I like this method is it seems very physical to me. So what I'm going to do here is that I'm going to hook this guy up to my circuit here. And one of the things that you see here, so if I come in and I insert the circuit, this is a fairly complicated circuit here. But you could see here, what if I do a Thevenin equivalent? So if I do a Thevenin equivalent, I have to sort of like pay attention to what I want to do here. So the first thing that I'm going to do to try to be clean so that when I go to node, I'm going to look at this node right here. This node is what we call V1. Now up here, I have another node. And what I'm going to do here is that I'm going to make this a Thevenin transformation. So that means here is that diamond I'm going to replace with a resistor and a source, voltage source in parallel. So let's draw this out again now. So now I have my circuit and it looks like this. So I have my ground here. And if I look at my ground, you could see here, so if I now do an equivalent, that means I have a source and I have a resistor. And so when I now look at that, note that I have a 30K and I also have a 10K right here. Okay, so when I'm looking at this thing, you could then see here is that this node now is this guy. And this is what I'm calling VTH. Of course, this is RTH right here. And then this is VTH right there. So why would I call that green node VTH? Well, remember, this node right here is V1. But V1 has a current of 0 in this branch. Because of this, it automatically kills off the R Thevenin resistor. So my real circuit really looks like that. So right here, I'm going to call this node vout. Okay, so I now know what my output node is right here. So let's go look at this thing here. So one of the things that you just saw me say here is that the ideal condition of I1 equal to I2 equals to 0, that implies that it kills off the R Thevenin resistor. That's why it's not in the circuit anymore. So what I'm going to do here is that, so what I really need is I need my Thevenin equivalent. So, you know what, maybe I should do this in a couple of steps. So if I redraw my circuit, just to be clear, the equivalent circuit is really this guy right here. I have my op amp, which is connected to the ground. I have a source which is V7. And then I have two resistors that look like this. So here's my 30K, here's my 10K, and that's the circuit I really got to solve. Okay, so this is the circuit, and my whole goal is to figure out this node voltage right there. So the first thing I got to do is I got to calculate VTH. So let's go do that. So what I need to do is that I need to calculate VTH. So if I calculate VTH, what am I really seeing here? Well, I have my green. So if I label my nodes again, there's that vout. Wrong. And then here's my V1 right here. And of course, there's my ground. So now let's start looking at this. So what I'm really looking at the circuit here, if I look at my Thevenin circuit, it comes here, and then I have my diamond. Then I have my source. And it looks like this. So I know this guy is 6 volts. This is 10K, 30K, 10K, 30K. So now if I color in my nodes, what do I know? This node is what we defined as vout. We defined this node right here as V1. So you can see that I have two nodes in between. I have an orange node right here. And I have a different node, maybe let's call this purple. And so what you're seeing here is that I really need to kind of figure out what that voltage is. So note, if I'm using simple circuits, V1 is equal to V2, which is 0. So in other words, this guy is the ground. So if I'm going to make a loop, it makes sense that if I want to calculate Vout, I called it vout. I really mean V7. So if I do that, I'm really going along this path to the ground like that. So I'm going to apply KVL along this path. And what you're seeing here is that if I look at KVL, it tells me that if I start at V7, now look at the polarity of this thing here. I can see here that there's going to be current that does what? Current flows in that direction, so that leaves plus minus, and then this guy is plus minus. But then I have plus minus here, and then I have plus minus here. I have two branches that are in parallel. So if they're in parallel with that 6-volt source here, then KVL tells me if I start and I go towards the right branch, then I have VTH plus, look at the voltage of the 30K. Again, it's the right branch. And then look at that. I get minus 10K. And then I get to the ground. So I know this must be the case right here. You know what? I think I have a sine error because I didn't do a complete loop. What it really should be is that VTH minus 0 should be the voltage across the 3K minus the voltage across the 10K. Okay, so again, this is following the right branch. So now if I look at this thing, you could see here is that now I'm going to use VDR to calculate V30K and V10K. So I see that then VTH is then going to be, the 30K has to be what? It has to be 10 plus 30 divided into 30 times 6 volts minus 10 plus 30 divided into 10 times 6 volts. And if I compute this, I'm going to get 3 volts for VTH. So now I know what that voltage is. So now I'm going to go back to my circuit. Here's my circuit, right? This is my circuit. So if I look at my circuit, what I'm seeing here is that the Thevenin equivalent circuit is this now. I'm going to paste this right here, and I could see here that now VTH is now 3 volts. So my whole goal is to figure out what the current is. Now, one thing that you got to remember here is that note that this current in this branch is 0. So if I'm looking at this, if I have 3 volts over a 10K, then that means that the current of the 10K goes this way, which then means that this current across the 30K has to be going up like this. It has to be going like that. So you're seeing how there's a flow of the current here. So now here we go. What I'm going to do here is that I'm going to apply KCL to the VTH node. So when you look at the VTH node, note that I have a current in this branch that tells me that I1 is equal to 0. I have a current that goes in this direction, that current here is the current of the 10K. And then I have this current that tells me it's coming up like this, and that's the current of the 30K, which is also the current of the output node. Now we got to be a little bit careful here because the output current node, let me be careful here, I shouldn't have said that. The output current should be going in this direction. So there's a minus sign. So this guy is really minus I output. So now I'm going to apply KCL. So if I apply KCL, what I'm seeing here is that I'm seeing what? I'm seeing here is that all of the currents coming in is going to be I out with the minus sign is then equal to I1 plus I10K. But we already agreed that this guy is 0. So I only have to look at the current of the 10K. So then here we go. So then the current of the output is then going to be minus that. So that should be Thevenin minus 0 divided by 10K. So then I'm going to get minus 0.33 milliamps for the output current. Now that I have the output current, I could now go calculate. No, I already did. There's VTH right there. So then the next method that I want to do here is I want to use the node method, where I write out the node equations. So let's go do that. So I'm going to come over here and I'm going to get the original circuit here. So here's my original circuit. I'm going to copy that. I'm going to bring it down here. Okay, so there's my original circuit right there. But this time what I'm going to do here is that I'm going to add some of the node colors that we already know. We know that this guy is ground. We called this node the output node. And I don't have a VTH anymore. So what I'm going to do here is that I know that's V1, so then I'm just going to start to move, going upwards. So I'm with this node right here. I'm going to call this node V3. I'm going to call this node right here V2. And then the green node, I'm going to call V4. So if I say, so what I've done here is that I've identified the nodes and counting shows that I have what? I have 4 nodes, right? I got the red, the orange, the green, and the violet. So I have 4 nodes, but I have 1 source. But that source is not connected to the ground. So therefore, I have 3 node equations where one of them must be a supernode between 2 and 3. So I'm going to have one equation that's going to be the supernode between 2 and 3. And then, of course, I need a super condition. And then you could see that I got node 1. I don't know what node 1 is. So I have node 1, and I don't know what node 4 is. So this guy is node 4. And then I have a 5th equation that has to be the ideal model. And what does that ideal model tells me? It tells me that, ooh, my notation is bad. I probably shouldn't have used 2 here, but you could see that really tells me, in this case, we've been calling it V1 equals to V2. And then I need a solver. I have an ideal condition, and then I'm going to need a solver for iout. Now remember, the standard direction of iout is down. So it looks like that. So let's start writing this out here. So what I'm going to do here is that note that this guy, this is my supernode. So I think I'm going to bring this down and then write the equations from here. So here I go. So if I write my equations, they're going to look something like this now. So let's look at the first equation. The first equation I'm going to use node 1. No, that's really not what the way I wrote it out here. So I'm going to use the supernode 2 and 3 and the super condition. So here we go. So I have a supernode between 2 and 3. So if I look at 2 and 3 here, you could see here, there's 2 resistors connected to 1. So I got a 30K and a 10K, but they're mutual. So I'm going to write minus 10 plus 30. And that's going to give me 1. That's the mutuals for that. And then I have node 2. Node 2 has like that. Now note, then I look at node 3. Node 3 has 2 resistors connected to it. And then finally, I have 2 mutual resistors with 4, which then means that has to be minus 10 plus 30 V4 equals to 0. There's my first one. Now let's go to the super condition. If I go to the supercondition, you could see here that 3 is the higher, this is the lower, and this is equal to 6. So then my third one is node 1. So let's go to node 1. So if I go to node 1, you could see that I have 2 resistors connected. So I should have what? 10 and 30. V1, then I have 2 mutuals. I have one with 3 and one with 2. So I have 10 with 2, and I have 30 with 3, and that's going to give me 0. Now I'm going to go to node 1. So if I go to node 1, you know what? I did not do this. I just did node 1. So I should have said node 1 right here. So I just did node 1. So node 4 is what I got to do. So now if I look at node 4 here, note that I have 1, 2, 3, 4 resistors connected. So I have 10, 2 10s, 2 30s, and they're connected to node 4. But then I have 3 mutuals. So if I look at the mutual, there's one connected to 2, there's one connected to 3, and there's one connected to vout. And 10 is connected to ground, so there I get 0. And then the next one that you see here is I'm going to use the ideal model condition. So the ideal model condition here essentially says, this is tricky here. This is really sort of like V2 prime really says that V1 minus V2 prime is equal to 0. You know what? I have to write ideal condition. Which then says V1 minus V2 prime is equal to 0. And then finally, I need a solver for I short circuit. Or iout, excuse me. So if I look at this thing, I need a solver here. So how do I look at this solver? So I need a solver for iout. Well, I'm going to look at the node V4. So if I look at the node V4, note that this really tells me that this should be V4 minus Vout should equal 30 times iout. So now I'm going to matrix this thing up and write a solution. So let's see how this comes out. So now I'm going to matrix up and get solution. So I have V1, V2, V3, V4. Then I have Vout, that's an unknown. And of course I have iout. So here we go. So what I'm going to do here, my unknowns then go something like this here. So I need V1. So I have 1 here, 1 right here, 1 right there, and then I'm going to keep going here. So if I do that, I'm then going to write what? So in this case, I have to write, man, this is going to get messy. So I got minus 10, minus 30. If I go to V2, I have 0. And if I go to the equation 3, I got 10 plus 30. And then if I go to 4, I have 0. And if I go to 5, I have 1. And if I go to 6, I got 0. So now let's go do V2. So if I look at V2, I have V2 here, 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 here. And then I'm just going to go down that line here. So if I look at that, I'm going to get what? I have 10 plus 30. So I have 10 plus 30. The next one is minus 1. So if I look at the 3 now, I get minus 10. The 4 is going to give me minus 30. The 5 is going to give me minus 1. And then the last one is 0. Okay, so you can see the start of my matrix. So now the next one I got to do is V3. So if I look at V3, here's V3 here, 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 and that's it. So here I go. So V3 gives me 10 and 30 and 1. So I get 10, 30, and 1. If I go to 3, I'm going to get minus 30. If I go to 4, I get minus 10. And then I have 0 and 0. Okay, so now let's go to V4. If I go to V4, I have one here, right here, and right there. So now if I look at the first one here, I'm going to get minus 10, minus 30. The second equation is 0. The third equation is 0. So let's write those in. So I got 0, 0. Now this guy has 2 10s and 2 30s. Then I have 0, and then I get 1. So now the next one I got to go after is that I got to go after vout. So if I look at vout, I have one here and I have one here. So I only have 2 spots. So the first 3 are 0. So I'm going to go 1, 2, 3. The first one is minus 30. The fifth one is 0. And then this guy's going to be minus 1. Now I need vout. So if I look at vout, here's what I see. I have vout only in one spot. So that means here is that this guy has to be 0, 0, 0, 0, 0. And this gives me minus 30. So now if I go get my constants, so the first constant is 0, 6, and 0. I'm going to get 0, 6, and 0. The next one is 0, 0, so they're all 0 after that. So there I get 1, 2, 3. Now, if I throw this into PSpice, not PSpice, into my calculator, I get a solution that reads Vout is plus 12 volts, and Iout is minus 0.33 milliamp. So I get the exact same answer.